Okay, so thank you for inviting me right here in this wonderful city of Porto. It's my first time here, so it's really nice being here. What I would like to talk about is, let's say, problem-based learning. Right? So the different type of teaching than what we are used to at this moment. I can move forward. There it is. Yes. So this is the way of teaching that we are used to, right? In high school, at university, we have a large group of individuals sitting in an auditorium, just like this, and the teacher is telling you what to do and what to know. This is really a one-way street of education, right? So a lot of information is coming from the teacher to the student, and there's not much coming back. Sometimes you have a question, but that's where it ends. But this is what we think is not a really effective way of teaching. There is some way of activity, but this person here, he always thinks, no, this is not working, right? So looking downwards. So because what we do here is we are actually transmitting knowledge, but we also know that our students at the end, when they go on their working environment, they need much more competencies than just knowledge. When we ask future employers of our students, what do you want our students to know or to do? It's not that they say, oh, they need to know a lot of knowledge. Most of the time, it's like they need to work together. They need to be able to think out of the box. They need to work to adapt to new situations, right? And these kinds of things we don't teach, right? At least not in this environment in which we put everybody in a lecture hall and you listen. And we think that at Maastricht University, we actually, when the university was initiated in the 70s of the past century, we immediately start with problem-based learning. And I would like to show you a little bit of how that works. But there are 4 key principles in problem-based learning, which is constructive learning, is contextual, collaborative, and self-directed. I want to go through all those 4 leading principles. Why is that an important issue in learning? So let's start with constructive learning. So when you think about constructive learning, I think the first key word I could come up with is activation. Right? So we have a lot of knowledge. And when students come into high school, from high school into the university, they already have a little bit of baggage that they can use, but they can't use it because usually it's hidden somewhere in their brains, and then they don't know how to activate it. Right? And that is something that we need to do. Right? So what we need to do is because you can gain new knowledge much better if you build on top of something that's already there, right? So you make a construction. But I want to have a little bit of a task for you, right? So just to show you how important prior knowledge actually is. Right? So you have that prior knowledge, and to understand the complex text, you actually need this prior knowledge to be activated. So I would like you to read the next text. I give you very short time, just because I only have 20 minutes, right? And then I would like to ask you, what is this about? I'm going to give you 10, 15 seconds to read it. Very difficult text, right? But what is this about? So because we don't have the context, we don't know what it is about, we cannot understand what is going on. If I would say this, it's soccer, and I give a picture, I didn't push out Ronaldo, I think that's right? So now the context makes sense, or the text makes sense, right? So you need to activate this prior knowledge, you need to know what it is about, then you can understand the more complex text that's in between. So activation is actually one of the major key keywords when we want to learn new things. We have something in there in our brain. If we want to add new knowledge on top of that, we have to activate the knowledge. The status keyword also in constructive alignment, so the building constructions in your brain more or less is that it is a structure, right? So you later on you will also be able to find that knowledge back in an easier way because you know the brain has its structure. Right? So in this way, knowledge is actually stored in our memory system. That makes it easier accessible, and therefore you can use it more easy and also can use it in multiple situations. Right? So what we actually do is on the right hand side, what we build our knowledge on something that's already there. So you use it as a hook, right? So then and then the new knowledge is on top of that. You create a new hook, and then new knowledge can be added on that again. And this way you create a long-term memory, and that's why then you can use that knowledge much more efficiently. You are activating your long-term, you're putting this new information into your long-term memory, and therefore you can. So when we talk about the principle number 1, constructive learning, so what we are talking about is activation of prior knowledge, right? So we need to activate the knowledge that's already there, because that new knowledge that old knowledge is needed to build the structure for new knowledge to come on top. Right? This is principle number 1. Principle number 2 is contextual learning. Right? So what we now often do is students have to read a certain chapter in the book, but I abstract, and then you don't know why should I use this, right? I think all of you had math in high school, right? Now we are scientists, we use math, but maybe at that time we thought, why do I have to learn all of that, right? Because you don't know what it is, why it is there, right? So there is no context, right? And that is also quite important, because you will also it's easier to store and retrieve information in your brain if you learn it within the relevant. So what you do is you go from abstract knowledge to, let's say, real life applications. So there's somebody coming in. So it helps students understand concepts, but also to transfer that knowledge to other situations. Because that's what I thought, what the next employer is what wants our students to do. They want to be able to have that knowledge, but apply it to new situations as well. Right? So therefore, we need to have knowledge, so we need to be able to transfer specific knowledge to a specific situation. And if the situation changes, maybe you have to use that same information in another way, or maybe you need other types. And in this case, you don't have to have all that knowledge in your head. Maybe you can also use AI to gain that knowledge. Right? So what we also need to do in this context is to teach the student to find reliable resources and also to judge those resources. Is this reliable? Yes or no. The critical thinking is, I think, a very important aspect. So principle 1 was constructive alignment, constructive learning. Principle 2 was contextual learning. So we try to because we use the same knowledge in different contexts, we try to teach a student that the knowledge can be transferred from one situation to the next. Principle 3 is collaborative learning. Again, a small task. List 15 sports that were part of the 2024 Summer Olympic Games in Paris. And I would ask you that as a single person, right? That would be different than when I ask you to do that in a group. Right? So if you would do this in a group instead of doing it by yourself, you can wonder, would the process be different? And would the outcome be different? Right? And I think both is true. Right? The process will be different because it's much more motivating, much more fun to do it together. Right? Also, science is becoming more and more, let's say, something like in which we collaborate. Right? The scientist doing all the work all by himself in the lab. Science doesn't exist anymore. Most of the scientists work together, right? And we have to teach the students already to work together because that's also more fun. And if teaching is fun, learning is fun, we also learn more and more effectively. And an outcome may also be different because your fellow student may maybe think about sports that you didn't think about, right? So your list will be longer, right? And then you can come up with motivation, and then you also have elaboration. And when you then do that, you can also can increase the knowledge that's already there, but just by working together. That's what we do as scientists. Like we work together. So therefore, this type of teaching could fit more into the real life situation. So we have constructive learning, contextual learning, collaborative learning. So we end up with motivation and elaboration. The last one would be self-directed. That is that what we are doing mostly in lecture halls is I am in the lead. Right? I am the teacher and I tell you what to do. But problem-based learning is actually the opposite. Right? So let's say a flipped classroom, what we also call it. So the student is in the lead. The student, and if we have the journalist and ask university, if I am a tutor, actually it goes very well. If it goes very well, I'm silent as a teacher. I'm not saying anything. And because the students are in the lead and they do the job. And then I will have an example because that sounds very abstract now, right? But I have an example how that works. You can do it short term, right? In Maastricht, we usually have tasks of a week. But I think in Toulouse, right, Bertrand, you have over several weeks. But you can also think about tasks that go for over 3 days. We work in small groups, 10 to 12 students, and we give those students a specific problem. And then they have to deal with that problem. And how do they deal with that? And we have always the same 7 steps. First step is, do we understand the problem? So the students read the problem, are there difficult words that we don't understand? Maybe we have to look that up first. But do we understand what this problem is about? Then they make what we call a problem statement, or they identify the major issue what is going on in that case, and then they do a brainstorm. In that brainstorm, they are activating the knowledge that they already have. Because this brainstorm is not, I Google it, or I ask AI. No, just what's in your head. What do you already know about that context? Right? So, about that problem. So they start activating the knowledge that they already have, and they also work together because somebody may say something and somebody else may add something to that. And then what we usually do in this brainstorm is we make a concept map that we have in all kinds of directions. What is this and what we have here, etc. Then we analyze and structure. So what do we already know? What do we know for sure? And then we also look at what don't we know? What do we still need to know to give an answer to the problem? And the original problem that was there. And from those gaps in knowledge that we have at that moment, we formulate at number 5 learning objectives. And I don't know what the structure of DNA is. For instance, what is the structure of DNA? That is then number 6, then we go study, which means the group leaves and everybody goes studying the structure of DNA individually. So you look for sources. You can ask AI, of course, but then we also have a discussion later on, maybe, is that a reliable source, yes or no? Right? So you can also discuss about where did you find it, how did you judge the importance of that resource, etc. Right? So that's why you can then discuss together. But first, the studying is individual. And that studying is not just, oh, I found the answer, copy paste and I'm done. No, because in step 7, you need to discuss your findings. You need to explain to each other what you found. And when you have to explain, that means that you have to understand. Right? Just having knowledge in your computer, that's not knowledge. Right? If I want to explain to you what the structure of DNA is, I need to have it in my head, and I don't have to read it from my computer. That's also why we sometimes ask our students, close your laptop and tabs. And if everything goes right, students do that all by themselves. They come up, for instance, with the structure of DNA without me as teacher having to add to that. Sometimes maybe asking some critical questions to reach more depth, right? But I don't tell them. If they go completely wrong, and I step in. So most of the work is done by the students. We had I give you one small example. This is what we did in the summer school in Hasselt. So there was the case was about air pollution in The Hague. The Hague is a city in the Netherlands. And what happened is, so the city, there are big streets and there are a lot of cars, and so there are inhabitants are concerned about the air pollution that's in their area. And with regard to Toxlearn, we came up with a case, with a problem. Actually, the problem was built around a letter written by a concerned citizen of The Hague, Mr. Worried, right? And he wrote a letter to the National Institute of Public Health, and you don't have to read it, but the idea is so that the students can read this letter, and then they can come up with all kinds of questions, getting it out of that letter, and trying to solve that problem. You can do that in weeks. You can also say, I just take one of those problems and I do that in a week. So you get a few days, right? So there is also some flexibility there on how to use it. There are all kinds of questions in there, like hazard and risk assessment. What is it? Exposure types and routes. So how are these people exposed? Via inhalation only, or is there maybe also something via the food coming in? You can look at individual susceptibility, because in that letter somewhere, Mr. Worried said that he's concerned for small children or the elderly. Right? So you have differences in susceptibility. Then you can move on. Right? He wants mitigating actions. What type of actions can you come up with? Right? And how reliable are they in the scientific literature? Right? So you can have all these kinds of questions. Students will go out, will investigate them individually, and then they move together and discuss them together. Eventually, we hope that in this way they will learn real-life situations, right? That is also then more attractive to what we expect from those students. That's what I wanted to say. Is it in time?
Yeah. Thank you very much. There any question from the no?
No questions.
And here? There's one.
I think we just could change the word problem to challenge. Maybe.
Yeah,
Maybe.
yeah. I think that's a good yeah. I think it's a good suggestion, right? Because yeah, it's a problem. It's semantics, I would say. But when we started in the 1970s at Martin, we called it problem-based learning, but you could also call it challenge-based learning. Maybe that's a nice one.
It's a positive word.
It's a positive word. Yeah, exactly. Yeah. So I agree with that. Yeah.
It's just related to this previous question. Is not problem different from challenge-based learning? Because I had the perception that it is.
Problem is a challenge, right? So what would be your perception then of a difference?
I think it's the length of the exercise.
Okay, yeah. What we noticed when we did our talks in our EU project, what we noticed was that our definitions for things differ between countries, right?
Okay.
Project-based learning, in the Netherlands, we do it very short. If you do it long, we call it project. We also have large group tutorials in which we actually do it differently.
And then
Right, so
it's challenge.
and then we call it challenge. So there are all kinds of different definitions for the same thing. I thought,
Yeah.
maybe you can add to that.
It's also.
Yeah, we have discussed quite well.
Because what we can have long project-based learning, but it's mostly something which is really concrete, something like project in the lab or project with the company, something really in space with real life. When our problem-based learning are more a bit like exercise, pedagogic exercise, that we want to, like, for example, kind of like not of fake, but yeah, created letters
Yeah.
to other topics. So it's more like
A simple newsletter,
Yeah.
a news item on a website can already be a case, right? So if you take, for instance, last year there was this hamburgers in the US. People were infected because they ate infected onions, I think, on the hamburgers, on the Big Mac. You can already make a case around that, right? Because what is the problem? Where did this infection come from, etc., etc.
I think that would be a challenge-based learning. Because it will take more time and it will take more development in something more structured. And while the problem is more focused, more immediate. So it.
Yeah, okay, yeah. But again, that is,
Maybe I'm.
no, but I understand the whole, but we even within the project, we have a lot of discussions about semantics, right? Because in France, problem-based learning is defined in a different way than in the Netherlands and maybe also here in Porto, right? But I think the concepts are all the same.
Yep.
Okay, so that, I think that is how you approach it, may be different, but the concept of activating the prior knowledge, and then these different stages, contextual work, I think these are all the same.
I think, Anna Teresa, I have a question. No, I think, okay, Alex.
Yes, Roger, very nice presentation, very clear, thank you. A challenge of TVL is time. In the course of 3 years, 4 years, or 5 years, the amount of knowledge that students need probably sometimes the challenge for TVL.
It's a problem.
Don't you agree? Because it takes a lot of time.
Yeah. Indeed, it does, but on one hand, it takes more time. On the other hand, the effectiveness is higher. Because if you can put in a lecture of 2 hours, right? But if you ask a student next week, or maybe in 2 weeks, what do you remember from that lecture? That will be very little, right? So indeed, it takes more time. But students learn much more than what you would think. Right? It's not just that they learn the learning goal of that case, because they also read a lot around it to find that solution. And so it's much more than just that problem.
You cannot go through all the issues, all the subjects that the student requires.
Yeah, you can, because we do that in mastering. You only have problem-based learning. You have lectures, right? But the lectures always after the PBL as a wrap-up, as a summary, to make it
We
more.
have lectures and apps, yes.
Yeah, we do have lectures, but they are the purpose of the lecture is different, because we always do the lecture after the PBL. So the students that are listening know already a lot about the subject, and therefore in your lecture you can give more examples and more in-depth situations.
So then it's mixed.
Yes.
I would say they're more engaged.
And more engaged, yeah.
Follow the lecture because they've done the problem before. They are more engaged in.
And then if you have a very complex lecture, students will drop out, right? Because they don't understand. If you first do your PBL, they know something about it, you can go into more depth in your lecture, and then they can follow it, right? So I think it's a good combination.
Fernando.
Yeah, no, I was asking, but I spoke already answered. Thank you very much for the presentation. I was asking what is the duration, the number of students per teacher?
Yeah.
Good.
We have 1 teacher for 12 students. That's one tutorial, that's 1 teacher. We work in courses of 6 weeks, and they meet 2 times a week. Right, so that is, and times 2 hours. So what we usually do is we pre-discussion on Monday, for instance, in which we discuss the problem and we come up with a learning goal. Then we come back on Thursday we discuss the findings about that, and we discuss the next case.
And how many students you are doing all the course?
The whole course, we have in environmental science, I'm teaching environmental sciences, we have approximately 300, 400 students. Which also means you need more teachers. You cannot do it with one teacher, because then you can say, okay, I fill an auditorium with all the students and I have one teacher, because he tells you what to do. You cannot do that in improvisation. So it's much more, it's more labor intensive. I have to agree.
It's part of the family of learning strategies. And that is the active learning strategies.
Yeah,
So
yeah.
it's a P family, and you have PBL, both problem and project. You have challenge, it's a different framework. You have then game-based,
Game-based, yeah.
team-based.
Yeah.
It's lots of different approaches, but it's active learning strategies.
Yes,
So,
yes.
um,
Yeah, so that was also the point that I want to make. You can give it different approaches, but the concepts remain the same, and all is that the student is actively participating in the teaching and not just consuming in the audience.
And, with that, we don't deny completely the lesson and the moment where the teacher presents complex ideas, and the lecture, it's of course important, but if we can bring principles of active lecture, I think it's also very important, because it's engage the students, bring their attention, make them be
Well,
more focused.
and maybe I can add to that, we also do more and more now, because we're talking about AI, or let's say electric tools in general. What we now more and more do in our lectures is, because the students have already prior knowledge, because they did problem-based learning first, in the lecture we ask questions. We do let's say quizzes, like online quizzes. Students log in with their phone and then they give the answer. You can see, okay, is the group understanding the concept, yes or no? Right. So that makes the lectures also more interactive. That makes them also more appealing. Right? Because I don't know whether other universities, but in the Netherlands in general, we see, because we record all the lectures, we see less and less students in the lecture halls, because I will watch them at that time. There's no engagement. But if you make it more attractive by also using all kinds of tools, right? By using, for instance, quizzes, that makes it also more appealing to show up and learn from that.
Yeah, you have a question?
It's more like absurd. Because he was saying regarding the time frame as a student, because I was a female student here in Universidad Aveiro, and it is indeed, and for the teachers and for the students, much more time consuming. But the truth is, it's more engaging during the entire semester, because I think here in Portugal, we still have a problem where all the exams are in the end of the semester. So we still go like we are very full of books, but we are not actively listening and studying. And I think with BBL, we are obliged to every single week to study and to take our notes and to discuss with our colleagues, because sometimes we find things that are different and sometimes completely opposite of what they find, because there are studies that tell us completely different things. And we need to actually also learn how to address these conflicts. And I think that's also something that is very nice for the future, for our work, to learn how to work in a group, because now I don't think anyone works alone. And just for the
Very nice. It's a very nice addition. Yes, because but it's also now, because what you say is when you have a lecture, you just mention once, then you want to study for your exam, you see it twice, right? But in problem-based learning, you see it actually 5 times. Because you have a team discussion, you look up your own results, you discuss it with other students, then you have maybe a lecture, and then you study for your exam. So you repeat it much more often, and that's why it's also restored.
That's what I'm saying. You need lectures as well. You need to have a combination of PBL and lectures. So all subjects, all matter that you want to address.
I agree with you, right? Because in the lecture then you can reach more depth actually.
Yeah.
But the purists in problem-based learning, at least at our university, they will disagree with you. But that's, I think everybody's opinion.
I'm sorry, I have some comments too, but we don't have
Yeah,
time.
okay, maybe in the discussion later.
Roger, thank you very much for interesting
Yeah,
talk.
okay.
Thank you.